Hello, everybody. My name is Chris Toomey with Mapbox, and I'm welcoming everyone to Visualizing Critical Location-Based Metrics on Serverless. Sorry, my coffee hasn't kicked in yet this morning. We've got a great webinar for you today. We've got Trevor Hansen from AWS and Austin Huminski and Katie Bays from IOPipe. So who is Mapbox and why are we all talking about this? The Mapbox platform is really comprised of, it's a developer platform comprised of 4 core components. We have maps, like we just saw. That includes data and technology for styling and rendering. Search, this is forward and reverse geocoding. Navigation, this is routing from place to place, multi-stop optimization, as well as Atlas, which is basically combines our core components and brings them onto your own on-premise scenarios. We support every developer out there, whether it's iOS, Android, Qt, Unity, or JavaScript. And we really are trying to empower people like AWS customers, like IOPipe customers, or IOPipe themselves to build fantastic applications and experiences using location. All told, we're touching 600 million people a day, generating 300 million miles of data to power real-time traffic. And we've collected at this point over 71 billion total miles of data. And this all comes from you. We mentioned the 600 million monthly active users. The idea is that as you start using our services or you start consuming data or start integrating Mapbox with your own applications, that generates a better map, which helps you get connected to more developers, which helps you reach more users, which then generates better data. So with this live flywheel is really here to help you and help your customers succeed. So, IOPipe is a close friend of ours. What we're going to demo today is something that's kind of a brilliant idea that IOPipe had that we wanted to help them enable. You can see other customers that have done the same. Everybody from USA Today and the Weather Channel to Snapchat, Facebook, Zillow, Tableau, and IBM. We're really here to help you with whatever you need. So what are we going to talk about today? Well, the idea here was as we were building a previous demo, our asset tracking solution, which is actually going live today, we got connected with the fine folks at IOPipe, and we said, hey, there's a lot of serverless in your tech, and we have a platform to help people extract that and monitor that and observe it and be more safe, secure, and scalable. We should partner up because we know there's location embedded in all of that. We don't know really how to take use of it. So that's where this conversation started. So we wanted to build this story for you. So we're going to start with talking about an intro to serverless, just to make sure we're all level set there. And we're going to feed that into the challenges of serverless observability, really seeing what happens inside your applications. And then we're going to move to this demo, thinking about how do we combine the data that's generated from your serverless platform, the location that's necessarily embedded in it from IP addresses, and all the great data that's coming from your invocations. And what happens when things go south? Like, when something blows up, something's running slow, where is it happening? Where are those requests coming from? And taking some techniques that Mapbox enables to visualize this data at scale, but also combine it with really fantastic modern tech like GraphQL and DynamoDB, so that we can really scale these things up out of the box. And then finally, pinpointing, we're going to focus on pinpointing Lambda timeouts and performance issues by location. The idea being that it's great to know that Lambda A is failing, but if those requests are all coming from, I don't know, the middle of, the Isle of Man, that's important to know. Like, it's not just an IP address, it actually has a physical location. So we're going to help paint this picture and show you how to accomplish something like this really quick. This is a demo that we hacked in about 96 hours because we wanted to know if it was actually possible to do this and do this quickly. Basically, we were stress testing both of our platforms. So without further ado, I'm going to hand it over to Trevor Hansen of AWS to kind of level set everybody on what serverless is and how it enables modern application development. Trevor, take it away.
Thanks a lot. So firstly, I'm really glad to be with you guys today. I'm really passionate about serverless and the journey that both partners on this webinar today have gone through. I've seen, the humble beginnings. I've been part of that journey, and I'm really excited by the pace of what they're doing. specifically around serverless. So just kind of to set the level playing field on serverless, I could imagine some of you are very familiar with it, but for those of you that are on the webinar that wants to kind of just get a bit of an overview at a high level of why is this relevant, what are the tooling landscapes, and what are the sort of benefits and use cases today. So as I said, I'm Trevor Hansen. I work with VC-backed startups at AWS. I mainly focus on DevOps and serverless, and obviously serverless has become one of my big passions. So kind of taking a step back, we're seeing that cloud has really enabled businesses to move a lot faster in their development and applications. So, you've seen companies born in the cloud and you're really, leveraging things like containers and you're really looking at how to move away from actually managing servers themselves. And then this new concept was born, this platform as a service and SaaS applications. And we saw that, things like Lambda and other serverless applications or services became available. So it's really starting to look at how do you abstract and move away from that undifferentiated heavy lifting. So, allowing your developers and, service teams to move a lot quicker. And the power really comes in when you start innovating, moving past that, having to keep things up and running. So we're seeing, today is the most exciting time in technology, given, how cloud is enabling businesses to move faster, and essentially working backwards from their customers. It's the competitive landscape has become really, interesting because all these companies are starting to leverage these really cool technologies to kind of speed up that workflow. And, customers are coming through, you're asking for specific features. You have traditional companies that are starting to implement new concepts like machine learning to improve that customer experience. And serverless kind of helps you speed up that rapid, the flywheel of getting that up and running. So, for example, in this demo, in the past, getting those applications up and running for a demo like this could take, 10 times longer, where serverless, you can kind of POC things, get things up and running really quickly and get that POC out there as quick as possible. So what does serverless actually mean for those that, have never really dabbled with serverless? I'll take a couple of steps back here. You really want to look at it that you don't actually have to SSH or connect to a server anymore. It's a service that's actually an API-driven service. It's really focused in providing you a feature or functionality or something that's going to be beneficial. So, for example, if we're looking at Lambda, you don't actually have to deal with the underlying servers. You're just actually providing your code and you're able to invocate that yourself. The next part is you want it to be able to scale automatically. You want it to be able to not have to go and deal with the, that heavy lifting of trying to define how it scales up and down. If you have X amount of requests come through as an enterprise company, that application will be able to scale to meet that requirements. And that's something our service teams spend a lot of time to ensure that those things are possible. Another really good benefit, if you're not running servers and having these serverless applications, it's really that pay as you use. If your application or company or your customer base is only online at a particular time, you're not actually spending per an hour, you're actually spending it down to the second. So this is really powerful, especially if you want to make sure that you're only paying for what you really need to be using. And then the last aspect is the service teams really want to focus on giving you the benefit of having that availability and fault tolerance built in. So you're actually going to have these services by design are already implemented across multiple different availability zones, so that when you're actually invocating that particular service, if it's Lambda, for example, it's going to be able to stand up and provide what it needs. So a couple of common use cases, and I don't want to dive too deep into this because I really want us to get into the demos and what this looks like from a actual implementation. But we're seeing at an early adoption, this is really coming out. It started off with that very back-end web applications where we saw people moving from that 3-tier web application to having static websites and having an API that would call something like Lambda on the back end, and that kind of ties into that back end. We're really seeing companies now starting to leverage that for their data processing, because that scalability is really powerful. You have data coming in, or it's IoT devices, or you're having stuff come out of, for example, like Mapbox. You're able to scale up to be able to process that as quick as possible and kind of deal with that mapping and reduce components. Lambda, I've seen customers looking at doing it in batching and so on. And there's a lot of different interesting use cases there. Another one we're we're seeing is chatbots is being able to have some logic sitting in in Lambda functions and being able to have this at the back end. I've personally built a couple of Alexa skills. We also have a service called Lex that allows you to create your own interactive chatbots experience. And then IT automation is definitely another interesting area. More enterprises moving to the cloud and starting to leverage, cloud applications. You're really seeing serverless become that little chewing gum in the middle of, different applications. And eventually they start realizing that they can start running some scheduling and policy engines and, really start using these things as small little things to ensure that things are done successfully and correctly. So that's kind of a high level. I'm happy to dive deeper with anyone that has any use cases that may sit outside of these. There's a lot of documentation, blogs, videos, etc., helping you understand how to achieve these. So when we looked at serverless and going into helping making sure that this is easy for customers to adopt, we really looked at how can this fit into your traditional sort of developer life cycle. So you would have, originally you're doing that prototyping, the POCs, you kind of established a really good use case. With this serverless application, you can kind of use things like, for example, the serverless application model and serverless, the CLI that we have, which is a SAM CLI. It can kind of clip into your IDE and be able to do some local debugging and testing. We also have some interesting partners that have done a fantastic job helping speed this up. Like, I'm working with companies like Pulumi and Stackery and HashiCorp around Terraform. You really want to see how, being able to move into that a lot quicker. And then you really want to start looking at how can this be easily deployed. So back to serverless application model, you can easily just, go SAM deploy, and it will package that code up and move it up into a Lambda function for you. And then the most critical part, and I think this is something we're definitely going to dive deeper today, is what does this look like from a monitoring aspect? You really want to understand, regardless how much scale you have there, monitoring is going to be critical to make sure that experience remains consistent. So video 3, kind of moving into serverless yourself, and this is something that I'm more than happy to dive deeper with you in. You're really moving towards, treating infrastructure as code. If you're not actually deploying your underlying infrastructure, applications at the moment, approach, using like CloudFormation or, serverless applications, serverless.com, you're able to create, this version controlled where you can repeatedly deploy this as you want. So this is something that due to scale quite successfully. Set up that automation around your integration and pipelines. You really want to have a good build pipeline in that. And, that's something that you want to make sure that your best version of your code gets out there into production, and you have the guardrails in place to kind of slow or stop any problems that get them. So the last is, I think I should have even put this one first, and I see they're all numbered number 1. But building and monitoring and observability from day one. If you start moving towards serverless, you have these distributed applications. They are, if you're a larger company that has, quite a few AWS accounts, you could have a lot of moving parts there, and just making sure that you're surfacing problems and pain points earlier than later, so that you can get more of a proactive approach in that. I think that's going to be critical. So as I said, we spend a lot of time with serverless. I'm going to be at reInvent myself. Please feel free to reach out. We're going to have, loads of workshops diving into each of these concepts I've spoken about. But I'm going to hand it over to IOPipe to kind of unpack what this looks like from their side. Thanks a lot.
Great. Thanks a lot, Trevor. So as he was saying, the observability around monitoring your Lambda functions still aren't quite as good as it was when you had traditional APMs monitoring your servers and EC2s. Developers still very much struggle with real-time and historical visibility into the behaviors of their application with traditional monitoring tools. Manually searching logs across dozens or hundreds of functions can eat up hours of your day while also trying to debug. What this means, the time to repair increases, draining engineering resources and creating business impacting disruptions. So the more time that you're spending debugging a problem going on with your serverless applications, that means it's time spent away from not building out core features and focusing on business logic. And you also just don't know what's going to happen until something does go wrong. You just can't predict what's going to happen. So having in place a robust monitoring solution that allows you to see how data is flowing through your application and your functions will help you make a lot of decisions and fixes pretty quick, and get you back on the line of developing the features and growing your business. So here enters IOPipe. IOPipe helps track, monitor, and visualize every single one of your invocations in your serverless apps, all in real time. So once you have some invocations in your functions, within seconds, you're going to be able to see those within the IOPipe dashboard. And we aggregate only on read, not on write, meaning that we don't sample any invocation information. So we store every single invocation. So when it comes time to debug and find that needle in the haystack, you'll be able to have the ability to drill down exactly to the invocations that you care about. We also have automatic HTTP traces inside your functions. These are helpful to see if it's your code or maybe external third-party API requests that are being the culprit for maybe slow invocation times or timeouts. We also actually just started rolling out database traces as well, so more to come there too. You can also get started with IOPipe without having to make any changes to your existing code. Basically, IOPipe takes advantage of AWS Lambda layers. So depending on what runtime you use, IOPipe has a layer for you. So you don't have to do any instrumentation to your function to get started and getting your functions monitored. So now we're going to show how we're pulling basically location-based metrics inside of IOPipe. So I have a sample application that we spun up together over the last couple of days. It's basically going to get a web request coming into our sample site, converting that IP address that we're going to get into a latitude and longitude to be stored in IOPipe. And then finally, we're going to be displaying that invocation on a map through Mapbox and their fantastic libraries. So we can kind of get a better picture of where our invocations are coming from to help kind of tell a better story about how our apps are being consumed globally. Sometimes seeing like another chart bar or metrics, random graphs don't really tell the full story. So we can ask interesting questions like, are we seeing certain cities or regions that are doing the majority of the traffic for our application? Why are we getting a random spike of traffic from New York City? Or maybe we're getting more traffic from the West Coast or the East Coast. Mapbox is going to allow us to visualize where our invocations are coming from to kind of help answer all these types of questions. So this is a kind of sample architecture of what this application is using. It was deployed or developed and deployed fully using the AWS Amplify framework. And if you're new to Amplify, it's a very, very powerful framework that helps you build totally flexible, scalable front-end and back-end serverless applications. So some of the pain points when developing JavaScript front-ends with serverless back-ends is that you end up with two different code repositories, basically creating two different applications. That makes it very hard to sync changes between the two, especially when you're handing off, say, different versions or different environments like dev, staging, and production. Often there's also a fair amount of boilerplate code that are involved to just set up a basic CRUD interface for maybe like a DynamoDB table. It could require the same 100 lines of code to implement the REST API over and over again. And Amplify really makes all this very simple for you. It has all their APIs and their command line interface to kind of get these things, this boilerplate stuff that takes up a lot of your time, minimize it down to maybe 10 lines of code. So if you have a web front end that needs a database, authorization with Cognito, an S3 bucket, GraphQL or API gateway, Amplify can do all these things, plus a lot more. They're rolling out features, it seems like, every month. And another plus is you'll never even have to go into the AWS console. You can deploy everything right through the CLI. Oops. So I'm going to share my screen now and kind of go over some of the steps of this application and kind of how it was built. That way you can kind of get a more context of how we're passing off the location data and the metrics to, there we go, to Mapbox.
So Austin, while you're bringing that up, would you mind kind of just setting the stage of the scenario we were talking about? Like, you know, what are we assuming here is happening? Is this a static site? Is this a bunch of just pure Lambda backends? Like, what's the context for the problem we're going to face here?
Yeah, absolutely. So this backend is going to be all through Lambda functions. So actually, I should should have gone back one more slide, but I have it up here too. So this application is going to be a React app. So we're going to be hosting the React app all within an S3 bucket. And basic users are going to come to the site, hit the static website and JS and CSS in S3, and it's going to make queries to our backends through AWS AppSync, which is AWS's managed GraphQL service. And then in GraphQL, you have different resolvers where you can go and get those data points from. So the two that we're going to be mainly focusing on today are these two Lambda functions. So a user is going to hit a certain endpoint. AppSync is going to take in the request and then route it to the appropriate Lambda function for the data to return back to the user. So the two functions that we have are one Lambda function that is going to return just the top 10 Hacker News posts from Hacker News. And then the other one is going to get the top 10 trending GitHub repositories from GitHub. And then there's also another part of the endpoints or a part of the app that you can write like a little to-do list to DynamoDB, but we're going to focus mainly on retrieving the IP address in the Lambda functions from AppSync itself, and then storing that in IO pipe so that we can later throw it into Mapbox.
And so we're assuming that, like, we expect these customers expect these applications. They run fast. They continuously are up. And what we're trying to avoid or detect is if there's instances where we're delivering a bad customer experience, right?
Yeah, absolutely. So we can see when we get the invocations on the map, we can see if we're getting a lot of errors or if we're having slow invocation time, and kind of drill into why we're having that particular issue and see exactly on the invocation level what could be the reasoning for some of these bad experiences. So I'm going to quickly just run through a little bit of the code so you can see how this is kind of flowing. So this is the high level, how the data is flowing. So when you have GraphQL, you have a schema basically, and you have queries about how you want to talk to different backends.
Awesome. Would you mind? I'm kind of having a hard time seeing. Would you mind like going full screen and zooming in a little bit?
Is that a little better?
Perfect.
Cool. So in GraphQL, you have different types and schemas. So for one endpoint, you can think of these queries as almost like separate endpoints. So this one query called get Hacker News posts is going to return back a list of Hacker News posts. And that's being defined right below here with this Hacker News post. So I'm saying I'm expecting to return an ID, a title, a URL, and who wrote the actual post itself. So when I go and query this, I expect to have multiple 0 or more of these type of Hacker News posts. And in the declaration on the right here, I have a decorator of @function, and this is the name of my Lambda function. So this is basically saying, when I have this particular query, go hit this Lambda function to return that data set to me, and then return it in the form of a list of all these Hacker News posts. And the same thing is going on for getting the trending GitHub repositories. It's just hitting a different Lambda invocation or function. And it's returning just a little bit different of a data structure back. So if you go into the kind of base application, the app.js of the React app, this is how we're actually querying and getting the post from Lambda. But you can see how easy it is with Amplify and their built-in libraries. All I have to do to get this operation is do an API.graphql, and then call the GraphQL operation with the Hacker News post query, which you kind of see is highlighted above my mouse there, which Amplify, when you create and push it up, auto-generates all these GraphQL queries for you. So you just have to import the query itself and then call it directly. So that's when this is happening, it's invoking a Lambda function and returning the results for me to display later onto the screen. And as for that Lambda invocation itself, this is the code that actually runs that invocation. So I'm using Hacker News' Firebase API. And what you can do in Amplify is they have recently released that you can do local mocking of the actual serverless tools itself. So you don't even have to deploy your apps into the AWS to kind of get an idea of how your application is going to work. So what we're able to do here is ignore if we're testing on local development, kind of ignore doing the metric thing, so we're just going to get local host. But if this is in production and it's being used and people are going to it, we're able to pull in the IP address from the Lambda event, and we can take it off the request headers and take it from the X-forwarded for, and grab the IP address that way. And then I'm also using a library to then, once we have that IP address, to kind of put geolocation coordinates for latitude and longitude. It's a GeoIP-Lite library. So once I get this back from me, I'm getting the latitude and longitude. And I'm also able to get a few other things from this library, like the city that it's coming from, the country, and the region. And what we're doing is storing these metrics as custom metrics in IOPipe. And I'm also storing it, the country, as a label in IOPipe. And I can show what that looks like in IOPipe itself. So this is the lowest level in IOPipe. It's an invocation record of an actual invocation that ran an hour ago from my function that was responsible for getting the Hacker News post. So I can see on this custom metrics tab all those metrics that we were showing before in the previous Lambda function. By doing context.iopipe.metric and then a key value and then another string or integer value, I'm able to see this data showing up into my invocation data. And then I'm also able to go over to the tracing tab and see all the HTTP requests that happened inside that invocation. So like I was saying, this function is in charge of getting the top 10 most recent Hacker News articles. So that's what each one of these individual calls are doing to Hacker News. And it's showing me how long it took in the whole response time or the duration of the actual invocation. And I'm also able to see the CloudWatch logs directly related to this invocation to kind of show if I had any debugging situations I need to put or to log out here, I'd be able to see all that right within the logs area. So this allows me to do some interesting things. I'm able to, if I'm curious about, if I'm wondering about all the invocations that are coming from New York City, I'm able to click on these and it will show me all the invocations from the Hacker News app. Maybe I'll go to a little bit longer of a time range, where New York was where the incoming request came from. And if I want to search across all my projects, I'll be able to see it where all these kind of give me an idea of what cities or countries that my requests are coming from. So to just go back and just finish off where this invocation is finishing up, it's going and taking the top 10 post IDs. Like we said, we were returning those. You saw those traces in there. And then it's returning the data just like in this format. So it's expected back from the GraphQL AppSync API. So that way, when we do this request, it's getting the data in a format that it's expected by. So it's nice to see how things are kind of showing up in IOPipe with just the, be able to sort by city and location and everything like that. But it's a little bit more interesting if we see those things on a map itself. So here is kind of what we hacked together. And I think I'll let Katie talk a little bit more detail about how this map is being built with Mapbox and how Mapbox made this whole experience a lot easier than we ever thought it could be.
Yeah. So everyone can hear me, right? Cool. Sorry. Yeah, so this has been a really interesting hack project that we've just been working on for a couple of days, again, to the point of kind of being able to spin things up pretty rapidly. And it's definitely still a interesting ongoing experiment. But basically, at IOPipe, we have a approach being that serverless is pretty much all we do here, aside from necessary services, of course, but we're very focused on the idea of breaking up our applications into smaller single function and being able to kind of watch those individual events as they happen in real time. So, when we're accustomed to aggregating a lot of these metrics over time, to be able to kind of pinpoint specific events, like, and based on metrics like duration, looking for cold starts, things like that, it was kind of an interesting new vector to start looking at location on top of that. So we decided to dive in, and obviously Mapbox provides a lot of really great tools to be able to try this. So I think Austin is showing a couple things, but for our purposes for this project, we brought in the turf library. And what we do on our end is we detect every time your function runs, if IOPipe is installed, we're going to see that invocation come through on our side. So when we're logging metrics for longitude and latitude on our side in the dashboard, we're going to pull those out, associated still with the invocation record, but map the longitude, latitude, and a number of other interesting metrics, like interesting pieces like cold start and errors and durations in milliseconds to GeoJSON using that turf library. And then once we have that, we can actually continue to calculate that in real time and then shoot that into a Mapbox, a Mapbox map embedded in our dashboard. So this has kind of been the fun we've been having. And I know Austin's showing the map. We've played with a couple things with filtering and just being able to kind of see those invocations as individual geographical events is pretty exciting for us. So we're kind of looking a little harder at other fun things we can do with this, but the initial direct mapping of in Mapbox language talking about individual features and an IOPipe language talking about individual invocations, graphing those to each other and seeing them visually, it's just an interesting new view.
So what Katie is bearing the lead a little bit here. What they're doing is, like, with the power of the IOPipe platform, is they're saying, like, we have all this rich data coming in real time, and it allows them and you and customers to say, I care about things that are slow at 100 milliseconds or 200 milliseconds or 10 milliseconds. You know, everyone gets to determine for themselves what that is, and being able to take that information and put it on a map, but not have to sacrifice that customer experience and flexibility really makes it a really straightforward process to build out these kind of rich experiences. Austin, if you wouldn't mind refreshing that page. I think you click the slow filter. So and I think you're a little too far zoomed in to show it actually filtering out. So if you want to run through that really quick and tell them what's going on behind the scenes.
And then you do it yourself.
I think I could probably actually switch to screen share as well. 1 second.
That's right, Katie, you're the one driving this. My apologies.
No, it's fine. I just didn't have the plugin installed before, but I'm going to go ahead and try. Let's see.
While Katie's.
Okay. Is that? There you go. Are you seeing this? Okay, cool. So, yeah, obviously there's two major players here, and I feel like I keep talking about Mapbox and Mapbox talking about IOPipe. Lovely. So here's our map. Obviously, we are randomly generating these, so we don't actually have someone in the middle of the ocean unless that's a mysterious tower there. But these are invocations that are coming through from the functions. You can see that data down here. The function ARNs themselves, but this is kind of what we've started playing with. What's really kind of neat about the, I guess, mapping these into this kind of structure where you have a lot of, you can just kind of plug in your properties and start to filter them down so you can really get at what potentially might be these problem areas in your application. I'm not sure, can you see outside the browser with this?
We can see your console.
Oh, okay, great. I just wanted to show a little bit there that we were able to kind of bring some of the stuff in here. And I was going to show a little bit of code, but here, real quick, like here we have some stuff, and we have some invocations showing up on the map. We have this updating in real time. So this currently is on a schedule that runs every minute. So it'll update every few seconds, just kind of checking for new invocations. And those are going to pop up on the map as well, which is also kind of a nice, powerful tool. But now if we want to filter down to, okay, show me functions over 100 milliseconds. And so now I can see what's going on there. And in the data, we're still working on the front end, but in the data, we can map those individual features to specific invocations and dive right in. And if we want to go really slow, I can actually see which ones are outliers here. So that immediately I can see not only are they outliers, but I can see where they were called. And I think that's kind of, I think seeing the interesting patterns that might happen within specific regions is kind of where we're getting excited about being able to play with this a little more. And then where I'm in good shape on errors. But yeah, being able to see the data and see something just popped up there. Being able to see new invocations come in a map is a really, just a different dimension compared to our usual charts, which I can kind of show. Like, we usually be just viewing these over time. And this is also very powerful. And what we tend to do is, just a demo, you can see invocations that are happening at a specific pinpointed time. So what we're looking at now is moving this into a map idea where we can see things over time at the same time that we're seeing things geographically. That makes sense.
Cool. That's awesome, Katie. I saw that point pop up immediately and thought that was really, it's always cool when you say real time and then all of a sudden it pops up.
Yeah.
So you're still sharing your screen. There we go. That's awesome. I think, Austin, is there anything else you or Katie want to add to the, before we start Q&A about the thought process or the experience, or why, or really the value proposition for what this type of looking at data like this in a new way, what does that help you do? And how you went from idea to some starter code to this final kind of this very early alpha type of feature. Like how did that work for you?
Oh, sorry. Yeah, so I think, I don't know, there are a couple of different ways that we could speak to this. I think that, I don't know, how to so, I mean, the speed that we were able to build it definitely made a huge impression, even in the last few hours, or possibly less than a couple of these things. I was able to bring in some of these methods from the Mapbox API and kind of bind them to filter events and kind of be able to spin them up. Like if I want to add like 100 milliseconds, 300 milliseconds, 900 milliseconds, if I want to really look at like kind of how far these metrics might go and kind of where those outliers might come, then I think that's been really valuable for us. I think that I don't know, seeing the recency and being able to, I guess, like something interesting here with working with GeoJSON is that we gather at IOPipe, we gather a lot of data. Our snapshots of the invocations themselves are incredibly fine-grained. They're very, we really, like, particularly if you have tracing going on your individual requests, where we have like HTTP and we've supported a number of databases, like you can really see a lot of what's going on there, which is great with our invocation record that Austin was showing earlier. And it's something that we really want to make it very easy to drill down to very quickly from a very high level. So it's this kind of fun other way of approaching it of like, I'm not looking at the last week, I'm looking at the whole world. and that we can simplify the data to look at this one specific vector, but still keep that complexity, I think is kind of where it gets to be really fun. Because when we're pulling out our records, we're really just pulling out invocation IDs at this first kind of proof of concept. We're really just kind of pulling out our records and pulling out the longitude and latitude and just a few pinpointed things that let me get to like the obvious problems really quickly. I think we're going to continue to build this out, but being able to kind of bubble up the most important and most interesting data very quickly without having to write many lines is a big deal for us. And it's a nice way to restructure our very rich data. We can kind of do whatever we want if we put the time in.
Cool. Thanks for that. We're going to go ahead and move to the Q&A. We have a couple of questions already coming in. I think the first one is starting at the high level. This might be a question for both Austin and Katie and Trevor. As you're moving towards these serverless architectures where you're depending on serverless more, I know Trevor mentioned you should start thinking about monitoring, but when's the right time to really start gathering this information?
I can speak on that a little bit. I really don't think it's right away is honestly probably like the best answer, because you're not going to know when something goes wrong. You're not going to expect it to have gone wrong. So it's better to just have some base instrumentation, just understanding the traces that are happening inside your invocations, understanding how the data is kind of flowing. Because once something does go wrong, you're going to be spending hours trying to debug that situation if you don't have the right things in place. So it's better to be safe than sorry. And also doing this type of instrumentation or setting up and monitoring your functions don't really take that much of overhead. Like I was saying before, there's a lot of solutions involved that you don't need to do any changes to your code. You just can attach a Lambda layer and be able to have full observability into all of your applications. And if you go ahead and create like new functions using the serverless framework, those functions will automatically be applied to the layer itself. So you have that visibility for any time you create any new functions. So really it's probably like a base thing to kind of get started with. Get your instrumentation or get your monitoring solution around, and then start building out your functions.
Cool. Trevor, any more commentary, or Katie, any more commentary on that as well?
Yeah, I would most probably challenge you to say that, just like any high performance car or, an airplane or anything that's going to be out there serving a customer base, the more visibility you have in what's going on, the better. Like being able to pick up problems at an earlier stage than a later stage, I think it's a powerful thing, especially if you're a large enterprise company and you've got hundreds of thousands of micro components out there that's serving your customers. You want to know where that little small old bug or something played into a region that you wouldn't even know was a problem, but having that information in front of you a lot sooner is going to just make you be more successful in any journey. Regardless if it's serverless or whatever platform it is, visibility is key. If you don't have any monitoring and visibility around these things, I guess we can all agree on that. That's pretty much just walking in the blind or walking in the dark. Sorry. So I would say that regardless how in depth you're going with it, I think it's an absolute must from the beginning. I think just having end-to-end visibility is crucial.
Cool. Thanks, Trevor. So we had another question. This is actually kind of a two-parter. This is asking about support for non-AWS backends, thinking about mixed or hybrid environments, such as probably multi-cloud or perhaps a mix of on-prem. So I'll pass this off to IOPipe as well. From a Mapbox perspective, we don't care. Like your data can come from your own services at any scale. Like if you have a massive Elasticsearch cluster and you're serving or something like Druid that has just a lot of data pumping through it, you as long as you're serving it in either vector tiles or GeoJSON, we'll render it. From a IOPipe perspective, I think this is an interesting question. Is there any from the IOPipe team? Can you comment on the availability of this type of monitoring in kind of a hybrid environment?
Yeah, I think that's really interesting because a lot of people, like the benefit you have with serverless is that you don't have to jump all right in. You can start migrating one piece at a time until you kind of get there. And it's a common thing that customers have kind of talked to us with because they see that the monitoring available within IOPipe for IOPipe with their functions, but they're not quite wanting to shift all of their workload there quite yet. They still have some legacy applications. So we have talked internally briefly a little bit about maybe covering some more popular frameworks like using Node and Express or Python and Django to kind of help you shift that observability from a traditional framework into your Lambda functions. So kind of sharing the same visibility and experience you would with your functions with the more popular frameworks.
So to follow up on that, Austin, can you comment on whether or not you mentioned Lambda layers, which is a great way to get started at AWS. Do you provide the same level of observability in like GCP or Azure or any of the other serverless providing clouds?
Yeah, so right now we're 100% AWS. It's not to say that we're not interested in using GCP or Azure or even our Cloudflare. It's just that we haven't had somebody come to us with demand yet. So we're very reactive based upon what our customers want and are asking for. So if someone comes to us and they say they have a big workload on Azure and they'd be very interested in having the IOPipe platform on there, it's definitely a discussion that we have. It's just so far the demand and I think the more popular realm has been AWS and Lambda on AWS.
And I think it's worth saying that in my experience, it's really not usually the serverless, for lack of a better word, framework, the serverless service, the Lambda or Azure functions that kind of tends to keep people on one cloud or another currently that I'm aware of. It's really like the things that are really hard to migrate and kind of like make it a different game are a lot of the other kind of data storage things that are kind of, just a lot more cumbersome to move things around and kind of be portable sometimes. So I think all that is really just to say that the approach of breaking up your actual compute time into efficient, kind of really honed in microservices that are really just running only when they need to run, being able to kind of get that very atomic visibility is something that, regardless of what cloud you're on right now, is really worth exploring, because I think that there are a lot of dimensions to look at it, but I think that it's something that's becoming. It's a really great way, if you haven't delved into it. It's just a really interesting way to kind of rethink how you run those processes. So explore it, whether or not you're on Lambda, I would say.
That's a really great point, Katie. And I think it actually leads me to a question of my own. I think this is probably for the team. And obviously, at Mapbox, we pride ourselves on documentation and developer experience. But since you are our customer in this context, given what you just said about thinking about how you break up your components and your services and where those responsibilities are, can you talk about, given that IOPipe is also probably a heavy serverless consumer, what sort of flexibility that gave you when you're trying to develop this new feature? You can talk about whether Mapbox was helpful or not in that, but just the flexibility that this approach grants you, regardless of the use of IOPipe, but just this approach of serverless.
Oh my gosh, I feel like, Austin, you could weigh in here too. This is really just like the speed of getting something deployed, and just not having to deal with the clunky kind of like structural things that you're used to with kind of more traditional instances, I guess. Austin, you could probably say more about that.
Yeah, I mean, totally. I mean, it seems like every month it's getting a little bit easier to deploy these serverless applications. I know from my experience, my major pain point was when I had like another project I needed to work on, trying to spin up proof of concepts. You had to go through a lot of hoops to kind of do all that. You needed to get an EC2 provision. You needed to have another database provision, and you might have had to go through lots of hoops, going through DevOps teams to kind of get that all provisioned for you. And then signed off with security groups to make sure that was all straight in the way. And you might still have to do a little bit of that now, but with the ease that you're able to deploy things, like especially like with AWS SAN and serverless framework and like Amplify framework that we were talking about a little bit earlier today, I was able to deploy every single one of those components. So I was able to deploy 2 Lambda functions, a DynamoDB table, and a managed GraphQL database all within my command line with maybe a total of 4 lines of command line interfaces. So it's the ease that you're able to do these things. So like, if we didn't have, if you only told us we had 92 hours and we couldn't use serverless, I wouldn't have probably even tried. It's just that it makes it that much easier to get these things rolling and out of the box and focus on what you care about, which is the actual features. And in most other cases, what the business is focusing on and wants you to put out there so the consumer can start enjoying it.
Yeah. And
sorry.
I was gonna say, Katie. So, Katie, to you, once you made that decision, like we're gonna take this application, and you said, all right, we needed to add this new feature, whether it's querying from the IOPipe backend or rendering that on a map. What was that developer experience like?
It was really, it was pretty smooth. I would say most of the process, like this is where we get back into kind of like processes and documentation, becoming familiar with the API, like the process, like the methods available there, and kind of how to apply them. And I think that with that familiarity already there, it's a lot faster, but it's a lot easy. I think to talk like directly about DX, it's hard not to talk about documentation with things like that, because delving into something new, sorry. The examples are really useful, and just having like a clear picture. It can be really fun when you're thinking about the kind of the data structure itself and going into kind of GeoJSON, which, to full disclosure, I hadn't really dove into in a couple of years. So going into some of the example like sources and kind of grabbing those out, it was just very interesting to kind of put them next to each other. Like, here's how we pull our data. Here's what it needs to look like for this tool. We can totally put these together. Like, they were very, it was very easy to kind of conceptualize how that was going to happen. And I think that it's also, it's worth saying, I'm heavily in JavaScript, and I think that's a very common language out there for a lot of tools. And I know Node is very popular also in Lambda, and I would say it's what we tend to see the most. But I think it's worth mentioning that with serverless, like, you really have a lot of flexibility in how, I think that somebody said, for like the ease of just being able to tack something onto an existing application with tools like Mapbox, but also with the way that you can kind of deploy new features and new services with Lambda very quickly without having to lift and shift or refactor other pieces. So it's very easy to think of new features as like very piecemeal, kind of ongoing things. And it's just kind of a cool, very flexible process, I would say.
Cool. Thanks. I think that's everyone's always interested. Like, yeah, I saw that. And I'm really curious as to how hard it is actually to build, which is a very unsubtle way of leading into our last slide for today. Mapbox is committed to open source. I know IOPipe is as well. And so we've made, Katie and Austin have made the thing that you saw today available on GitHub. You can see the link here. Any instructions, thoughts, pirate jokes you want to tell to get getting people started with what they've seen today?
I'm not too funny, so I'll spare you all the jokes. But so the GitHub repository is for deploying the Amplify framework that has kind of allows you to deploy the functions and the DynamoDB tables. There are instructions there how you would deploy that environment. You should be able to spin up your, as long as you have an AWS account, be able to spin up all those things. And then it will also have in those functions the ability to take in the IP address and store them as custom metrics in IOPipe. And then probably, and then Katie and I and Chris and I, we were all talking about how we kind of had a lot of fun doing this and might go a little further and try to finish it and have a more of a polished type of example. So that might be something that once we spend a little bit more time with release, to be able to see how we kind of built the map as well, since it was integrated directly within the IOPipe dashboards, it was a little bit more hard to share. But that's probably something that I imagine would be interested in doing in a little bit.
So I can put you down for Q1 2020 to have this as a new feature?
Sure, why not?
Tomorrow. Definitely tomorrow.
All right.
I will say the pirate day explains that we have some client requests coming from the middle of the ocean.
There you go.
Puts a lot in context for me.
There's a reason.
All right, guys, swashbuckling Lambda function. That's really good. I think that's probably a good time to call it. We don't have any questions left. We appreciate everyone for joining. To Katie and Austin, thanks for building an amazing demo and for having an awesome platform. Trevor, always a pleasure to work with you again, and thank you for sharing your deep knowledge of serverless and AWS with everybody. As I mentioned at the top, I'm Chris, Solutions Architect for Mapbox. If any of you have any questions about what you've seen here today, you want to get started, you can come to mapbox.com, go sign up at AWS, go to check out IOPipe. We're here to help. We want to make you be successful building amazing things and scaling them to millions of people. So thanks again for coming. Hope you all enjoyed all of it. And both the recording and questions, I believe, will be made available afterwards. So thanks a lot for tuning in, and I hope you have a great rest of your day.